Hello again, Mrs. Thompson here, and today we're talking about net ionic equations. I want to show you an animation, and I don't expect that you write any of this down. Just watch so you get a better understanding of what's going on in a solution as two ionic compounds are added. This animation is here just to give you a visual of what's going on when two things that are soluble in water come together to form a precipitate. So here we have silver nitrate, aqueous when it's in water, means it's soluble, it will dissolve, and sodium chloride, and then it's going to form some silver chloride. So here we go, these two are falling into the water, and immediately when they hit the water, they separate into their ion forms. The water molecules pull them apart. And so the silver and the nitrate and the sodium and the chloride just kind of bounce around in the water and move about their business. Eventually, you see something like silver chloride forming, a precipitate, a solid that forms, because those two together will not dissolve in water, and so they stick together. When sodium hits nitrate, those two do not form a precipitate, and they just continue to float around in the solution. If you add a whole bunch of them, a bunch of silvers find a bunch of chlorines, a bunch of sodiums just keep floating around, and then you end up with a pile of silver chloride ions. Okay, this is describing what's going on in this beaker of solution. So you have silver and nitrate floating around, you have sodium and chlorine floating around, and then after a while, some products start to form. That's what this arrow is here for. And you see solid silver chloride, and then you still see some nitrate floating around and some sodium floating around. So our products end up looking like this, where we have one that's a solid, we call our precipitate, and then the other two are sodium and nitrate ions. Okay, let's watch this again. Those two form ions in solution. The silver then finds the chlorine, not intentionally, but they do what we call a reaction. It's the only thing that's actually reacting is the silver coming together with the chlorine. The sodium and the nitrate are not reacting. They're just floating around in the solution. And since they're watching this reaction happen, we have a new name for those two. We call them spectator ions because they're just watching. They're not participating in the reaction at all. Like as if you were going to a basketball game and you were watching in the crowd, you would be a spectator in that crowd. You wouldn't actually be playing the game and you wouldn't have any impact on the outcome of the game. The only two in this solution that are the silver ions and the chlorine ions. They're doing actual reaction. They're forming a precipitate. Okay. And so if we can make what we call a net ionic equation, in a net ionic equation, the only thing that we show is what's actually happening, what's actually reacting, and get rid of the things that are just watching. So as far as the things that form an actual product, a solid here, we have silver and chlorine forming silver chloride. Then what's not reacting are the nitrate and this, because it's aqueous to begin with and aqueous after the reaction happens. And then also the sodium ions are aqueous to begin with and aqueous after. So those are our spectators. Those are just the ones that we're watching. And so in a net ionic equation, we would get rid of those spectators, cross them out, say they're just watching. And we would write an overall net ionic equation with everything that is left over. So the silver ions and the chlorine ions, okay, those are the ones reacting and forming the silver chloride. And that would be considered our net ionic equation. Okay, so some parts of a net ionic equation, some I went over. Now you are supposed to start writing again. First is the molecular equation. That's what you start out with. It's the regular balanced equation. Then you have the total ionic equation, which is sometimes called the complete ionic equation. And this is when everything is broken up that can be. So everything that's aqueous gets broken up into its cation and anion. and anything that isn't aqueous stays together. So solids, liquids, and gases stay whole. Then you have a net ionic equation, which is the overall equation, the thing that's happening, the reaction that's happening. It's with all of the spectator ions removed. And then what are spectator ions? Spectator ions are ions that do not participate in the reaction. They are things that are aqueous as a reactant and aqueous as a product. And so they do nothing. There's no change in those. Okay, there are three driving forces for reactions to happen in things like a double replacement reaction or even a single replacement reaction. And one is that a solid forms. For example, a precipitate forming. Another is a gas forming, like carbon dioxide or hydrogen sulfide gas, or maybe even one of the diatomic elements like bromine, iodine, or chlorine. And then the last one is liquid forming. So an example of that would be an acid-base reaction where one of the products is water. Okay, so some sort of change has to happen when you mix the two together, like forming a cloudy precipitate. And if that doesn't happen, we say that no reaction has taken place. All right, so we're going to go through two examples, and we're going to write the molecular, which is the balanced reaction already done. Normal reactions is what we're used to. Then the total ionic, split up, and then the net ionic, what's left over after you get rid of the spectators. Okay, so we're going to go through and we're going to split up anything that has an AQ next to it. So this first one has an AQ next to it. Okay, I have sodium ions, and I'm going to put their charges. Sodium is in group 1A, so it's a 1+, and I'm going to give it its AQ because it had AQ to begin with. And then I'm going to say how many of each one. So because there is a 2 subscript here, that tells me I have 2 sodiums in total, so I had to include that here. And then I also have carbonate. We don't have parentheses around the carbonate, and there isn't a coefficient, so we just have one carbonate. So it's breaking up into sodium and carbonate. We're going to split those with a plus sign. Okay, so that one was aqueous, split it. Next one, we have calcium and nitrate, and again, it's aqueous, so we're also going to split this one up. All right, so we'll have calcium. Calcium is in group 2A. It's a 2+ charge, so you have to look up those charges. And then you have nitrate. It's NO3 with a 1- charge. It's what's inside of the parentheses. And then outside of the parentheses, you have a 2. That means that you have 2 nitrates. So we're going to put a 2 in front of the nitrate. Okay. Then we're going to split them up with a plus sign just to say this is separate from that one. And then also, because these are 2 different things, we're going to put a plus sign here. So I've got all of these split up into ions for the reactant side. This is what it starts out as. This is what it goes into the solution before a reaction has happened. Okay, you have your arrows still. Our next compound is calcium carbonate, and it has an S next to it. That means it's solid. Anything that's solid, liquid, gas, you cannot break up. The only thing you can break up is something that's aqueous. Okay, so that means that's going to stay just like that. I'm not splitting it up at all. Okay, plus we have sodium nitrate. That is aqueous. And we have a coefficient, so we have to watch out for that. That 2 is going to be distributed throughout. It's going to be 2 sodiums and 2 nitrates. Let's split that up. Sodium is in group 1A, it's a 1+. Nitrate is a 1-, and there are 2 of the nitrates because of this 2 here. There are also 2 sodiums, and we're going to split those 2 up with a plus sign. Okay, no reason for this to be underneath. I just ran out of room. All right, so here is my total ionic. Everything is broken up that's aqueous. The thing that's solid has stayed together. Okay. Next, I'm going to find the spectator ions. So those are things that are aqueous on both sides of the reaction. So if I look at sodium, it is aqueous here. And then on the right side of the reaction, it is also aqueous. Notice I have 2 sodiums here and 2 sodiums there. This should always happen, okay, if you balanced it correctly to begin with, and then you're carefully adding your coefficients to say how many you have. This should always work out. You should have this correct number of coefficients, or correct number of atoms. So we're going to cancel out sodium and call it a spectator because it didn't do anything. It didn't change. It went from aqueous to aqueous. Okay. And then we'll check carbonate. Here it's aqueous, but over here carbonate is a part of the solid, so I cannot cancel out carbonate. It is actually doing something. It's changing into calcium carbonate. Same thing for calcium. It's aqueous here, but solid over there. Okay. And then the nitrate, we have 2 nitrates on the left side of the arrow, that's aqueous, and 2 nitrates on the right side, that's aqueous. So those 2 can cancel. So I'll cancel those 2 out. Okay, so if I have to identify the spectators, I would say that sodium and nitrate are the spectators in this reaction. Okay. The net ionic equation is just everything that's left over that we haven't crossed out, so all we have to do is bring that stuff down. So it's carbonate and calcium makes calcium carbonate. And again, this should already be balanced if everything else is taken care of in the beginning. All right, survived your first net ionic equation. Let's try another. Okay, so here we have a single replacement reaction with chlorine and aluminum bromide. The chlorine is replacing the bromine in the aluminum bromide compound. Okay, and it can do that because it's more reactive or active than bromine is. Okay, so remember that we can only break up things that are aqueous. So then we have gas here and gas here that cannot be broken up. All right, so let's break up the aqueous. This is the first one. We have aluminum. Aluminum is in group 3A. It's a 3+ charge, so don't forget to add that. And we have 2 of them because I have a coefficient of 2. Okay, and then bromine. Bromine is in group 7A. It's a 1-. Okay, here's the tricky part. I have 3 bromine in the formula itself, but I also have this coefficient. So because of the coefficient, altogether, I have 2 times 3. I have 6 bromine ions. Okay, and then we just separate it with a plus sign. Okay, for the chlorine, it is a gas, so I can't do anything to it. I'm just going to write it as is and put the 3 in front. That's an arrow. Okay, this one can be broken up, okay, because it's aqueous, so let's do that. Okay, aluminum again, 3+. There's a coefficient of 2. Chlorine is a 1-. We'll separate it with a plus sign. For the aluminum, with the coefficient of 2, I added the 2 in front here. For the chlorine, see if you can guess what that's supposed to be. Okay, so it's 2 times the 3 gives me 6 chlorines. So don't try to tell me that there's 2 Cl3 with a crazy, I don't know what minus charge, but you have to go back to what it would normally be as an ion, chlorine with a 1-, and then count how many chlorines with a 1- you would get in this whole thing. Okay, and then we have this one, which is a gas, so I can't break that one up, so just plus 3Br2. Okay, looks like we have everything broken up that we can. I'm going to look for spectators now. So spectators, again, are things that were aqueous on the left of the arrow and the right of the arrow, and it just means they didn't do anything in the reaction. Okay, so let's check aluminum. Over here, it's aqueous, and over here, it's aqueous, so cancel those out. Okay, and then bromine, not aqueous here, but gas here. And then chlorine, gas here, aqueous there. So I can't cancel either one of those. So with my net ionic equation, I'm just going to write everything that is left. Okay. There are links to other videos about this on my website. You're welcome to look at more, as these do get a little bit complicated because you are dissociating different ionic compounds and then putting them back together. So bring some questions to class. See you next time.